Well, my name is Daniel. I am a senior project manager at Sustainable Innovation, but I also work for ViaEurope as some kind of project janitor, and we are developing something that we call EnergyNet.
Daniel, one more question. Please slow down because there's simultaneous translation. Remember, Ukraine, they all speak Ukrainian, so we do our best. So thank you.
So what EnergyNet is a system description of different components. These are 3 different components. And these are interoperability between energy assets, such as generation and storage, but also distribution and metering and so on. It's also about digitalization of the power grid, so distributed control in real-time monitoring and control through an open platform using software and open source principles for communication and control. Now, this sounds perhaps complicated, but it essentially means that instead of being reliant on the old grid to function in order for you to get power, in order to distribute power, you get more control and more decentralized control in real time than before. So the first part is the platform operator, which is sort of a new way to interact with a distribution service provider. Instead of being locked into the same service provider or the same DSO, you can get access to this kind of more open energy sharing operator. I'm trying to be, but here's the cool part. So this is an energy router. This router is placed behind the meter inside a building. Now, this is for a multi-home apartment building, but for an industrial park, this would just be a bigger version of this with thicker cables and bigger connections using DC currents, or high voltage DC current. And this is placed behind the meter. It is port-based technology, much like an internet router in your home if you have fiber connection, broadband connection through that. And it distributes energy through the router between the ports depending on whatever you need. And here you connect your photovoltaics, your battery systems, your consumption, your production capabilities if it's machines and so on. And it uses an open energy protocol for communication. It is also galvanized in the sense that you can connect as much production behind the meter as you want without negatively impacting the overlying grid or being limited by the overlying grid or the old low voltage grid. Another feature with this is that if you connect 2 routers with each other, you can distribute energy between these 2 routers. If you connect 3 energy routers with each other, now you have a meshed network. You have a web network. And then as you connect more routers, you get the network effect. This means that an energy router can both deal with production, consumption, and distribution in real time. And as you connect more and more routers, you get a system with no single point of failure for distribution of energy. You can have in a large manufacturing site, for example, you could have multiple energy routers placed throughout the facility in order to monitor and control energy flows and production flows. And if something really bad happens, you can also have prioritized automated sequences for which machines are going to be turned off first, or HVAC going to be turned off first, in order to do load balancing and lots of other cool stuff. The key point here is that it becomes an edge upgrade, which is called, for a building. Doesn't matter if it's a dwelling or if it's a production facility, that makes that you have full and complete control over what happens. The communication is done through 2 parts. One part is cloud communication. You see the small antennas. And the other part is power line communication through the cable. So each cable is monitored and controlled in real time. And that is how, when we connect multiple routers with each other, then we get these kind of meshed networks of power distribution, where it doesn't matter if you take out 3 routers, as long as the other routers are still intact and the lines are intact, you can still distribute energy throughout the whole system design of where these are going to be built. So here we can see an example where the green blobs are the energy routers, and in our initial stage now we are building for properties, but the fundamentals are the same for any factory or production facility. It's just bigger or just more of them. There's no fundamental design that needs to be adapted or changed a lot. So the core components are just come from the EV industry, where we combine them in a new way. So in that regard, there's no new magic sauce that needed to be done. The uniqueness is how we combine it and combined with the Open Energy Protocol, where the Open Energy Protocol is important because it enables you to pick and choose whichever battery system, PV system, or other type, or HVAC system, or manufacturing system that you want, and you can mix and match. So you're never locked into the single leverantör in Swedish. It's
single source point.
Single source. Thank you. So this means that, for example, is unlimited photovoltaics behind the meter. Unlimited in the sense that you don't need to care about what the old grid is capable of absorbing. As long as you have energy routers, the energy router can take care of all of the security measures that are needed in order to make sure that the frequency is maintained and the voltage is maintained. And as you connect the routers, it will distribute the energy behind the meter. There's no single point of failure for distribution, meaning that if you would live in an area with EnergyNet, it doesn't matter if 50% of the buildings are destroyed or taken out, you can still distribute energy through the rest of the power grid. You can equally as much then support the old grid that is connected by routing energy through the EnergyNet to the old grid if something bad happens. It also means that it's the next generation of power distribution technology based on open source principles. And we are quite firmly believer of open source principles, that we as ViaEurope, we deliver the service of running and operating the routers, the energy router, the hardware and the infrastructure. However, we are also building them in such a way and designing them with open source principles that if you would find a local Ukrainian operator in the end, you could just change because you don't like us and you want to have local, and that's fine. We think that we will deliver value by being good and not locking our customers into bad technology. And having access to this also means that other third-party service providers in the long run can provide other types of services that we don't currently know about. It could be aggregation, load balancing, frequency maintenance. It could be EV charging, and many other things. So you told me to keep it short, so I kept it short.
Daniel,
So